Welcome everybody to the February W7PRA monthly meeting. I'm Paul N0 VLR, chair of the board. Let's see if we can start with some introductions. I'll go around like Hollywood squares on my left top, and that would be Paul. Go ahead.
Paul Branchfield, W7PEB from the Southern contingent from Roseburg.
Nice. Thanks for representing. Mike?
I'm Mike, W7RIS, located about 10 miles north of Corvallis, Oregon.
Terry, you're up.
I'm in Northeast Corvallis and KJ7 KAU.
Thank you for the reminder on the call sign, Terry. It's been a while. And how about Mr. Ty? Oh, I think you're on mute. I think you're on mute, Ty.
Okay, we'll try again. Ty Parsons, WB7DD, Southeast Corvallis.
Awesome. Thanks for being here, Ty. Ron?
Yeah, Ron Post, AE4JL up in Millersburg.
Good to have you, Ron. John?
Sean Shod, K7JU, South Eugene.
Thank you for checking in, representing Eugene.
I missed a lot of meetings. I managed to make it this time.
Yeah, well, welcome. Glad you have it. Larry?
Oh, this is Larry, AF7NU in Northwest Corvallis.
Thanks for coming.
Northeast Corvallis.
Good to see you at the Hamfest last week, or this past weekend. And Julie, if you want to introduce, feel free.
Hi, it's Julie, AI7SO in North Corvallis.
All right, thanks for joining us tonight. Well, we're going to flip the script from the last few months. We're going to go ahead and start with Mike, and he's going to do a training session of a mysterious topic because I don't know what it is, and so he'll tell us. But we do appreciate Mike and his educational component. We're going to keep this on record so that we can put it out on our channel that we do. I would ask for everybody to just mute their mics so that we give Mike a clear pathway to do that. And if Mike, I'll let everybody know how you would like to handle any questions. Take it away.
Sure. Just a moment here. Get things up. And thing. Okay, everybody should see a nice big blue screen that says alternate emergency power. Everybody see that? Okay, cool. So previous times I did a discussion on using generators, and generators are always kind of a preferred way of providing alternate power when our mains are down, when we don't have commercial power out there to operate our house and operate our equipment. So things that we're going to talk about is types of emergency electrical power sources, and except for generators, we've already done that. Previous programs, we talked about generators and emergency power. This program is going to focus on alternates. There's a bunch of other sources out there that we can have for alternate power, and there's things to consider. There's never one of these perfect solutions. So we'll look at the good and the bad about some of these alternate powers. We'll talk about how to connect your generator or your alternate power to your house. We'll talk about strategies on how much power do you really, really need, and a little bit about safety. So previous program, we talked about when we look at our house and we want to bring in some alternate power to keep things alive and keep our creature comfort, we need to kind of look at what we absolutely have to have, what is nice to have, and what is really a luxury. Because a lot of times when we generate extra power, emergency power, we don't always have the ability to run the entire house. And when we do run the entire house, it starts getting a little expensive to do all of that. So we want to end up making sure that where we spend our money is in the right places there. So, let's first talk about solar. So solar and wind power are very, very similar to that. But we're going to talk about solar in particular. And so I think everybody understands that those are those panels you put up on the solar vac panels that you put up on your house. And then you have some electronics that changes that DC power that you get up on top of your house into something that you can use in your house. Now, one of the things that we have today is that we've kind of gone away from having the expense of having batteries in the house. And so why has that happened? What we're do these days is that we generate solar power, we sell it back to our power provider, Consumer Power or Pacific Power, whoever it is. And then we end up taking some of that power and we use to run our house. So typically during the summer, we can create an abundance of power and sell plenty of it back to the power generation people. During the winter, we typically can't create anywhere enough to take and run our entire house. And we end up not putting much energy back onto the power grid out there, but we have just a little bit of power that we use in the house, and we use the rest of the power grid to take and provide our power for us. Now, another thing that we would normally use batteries for is at nighttime. At nighttime, obviously, we don't have any solar activity out there, so it'd be nice to be able to store those things in batteries. One thing to be very concerned about is if you don't have a storage system on your house of batteries for storing that energy, those solar panels out there do not do any good as far as creating energy that you can use in the house when the power system is down. So if like during the even during the summer, during the winter, anytime that you have a power outage and you think that you're going to be able to use those solar panels up on top of your house to take and run your house, if you don't have commercial power or if you don't have batteries, you have to have batteries, you cannot use that system out there. So that's a real substantial drawback for you. We'll take a look and see how some of this works out. So let's see. So one thing I'll point out during the winter, that because of the low angle for us living here in the northern hemisphere, that low angle of where that sun is, those photons have to go through an awful lot of air and a lot of stuff that's wrapped around the world here. And that filters out a huge amount of the solar energy that we could use for generating solar power. And so thereby our generation ability is very, very minimal when we get into the winter time frame. So I'm involved with probably 2-3 other repeaters, and I have other things that I'm involved with. I got a really cool weather station, but we can get cloud cover that's thick enough and prolonged enough where we can go at least 3+ days without sufficient solar energy to recharge our batteries. So if you're thinking about wanting to use solar power with batteries and you want to be able to keep whatever your system up and running, you have to think about, you have to have enough battery to keep that house or keep your appliances working for 3+ days. We've actually had 2 instances this winter where we had insufficient power to keep our batteries up for more than 3 days. Now, so fortunately, the way that you compensate for, you more batteries in. You put more solar energy or more solar panels and more batteries there to end up giving you that gap and get you over that 3-day hump. If you generate electricity locally, you need somewhere to store those batteries. So that's the key, store the energy. So that's the key thing is if you want to be able to store it, you got to have some kind of a battery system. You got to have some way of storing that stuff. So let's talk about some alternate ways out there. So one of the things that's kind of recently come on the market, and that's one of the companies is called EcoFlow. And those you can see down on the right-hand panel there. So that's a box that has a whole bunch of lithium batteries in it and has an inverter, and that inverter then feeds that power panel above there. So that box there weighs about 100 pounds, and it's on rollers, so it's pretty easy to roll around. So these devices, and actually there's another one here, and it's not real clear, but another one in that left panel there, it shows a little pony pack that goes with it. So you can add these little pony packs on there, and you can get a pretty substantial amount of storage out of that. So typically one of those pony packs will give you 120 volts. If you put two of those controllers together, you can actually get 220 volts. So if you want to take and run a water pump, if you want to run electric range, if you have heating in the house, like a heat pump, you need 220 for that. If you have a water heater, you need 220 for that. So if you want to run any of these bigger appliances, you got to step up to a 220 volt system. If all you're interested in is keeping your refrigerator running so you can keep your beer and pizza cold, running a TV, running a couple lights in the house, these things will work just fine. But let's take a look at some of the limitations. So the basic base unit on one of those things is usually around 3.6 kilowatts. Typical house needs about 30 kilowatts a day to operate. Now you can go through there and trim that down, as far as not running any of your heavy duty appliances. If you kick on your water heater, you're going to be using lots of energy and it's going to deplete those batteries in a big hurry. So you can expand these things up to about 25 kilowatts. So that'll give you if you're very cautious on how you use your electricity, you can probably get 2 to 3 days out of that. So an output on that is anywhere from 3.6 to about 7.2 kilowatts. So that 7.2 is probably just enough to run a water pump, run a hot water heater, things like that. But you do not want to run them very long at that higher output because it'll deplete those batteries really quickly. One of the big selling points that they have is if you can recharge these things using solar power or from another generator or from the grid once the grid power comes back on. But think about it, the solar power. If you need to recharge your system there with even 3.6 kilowatts, that means you're going to need probably about 15, 20, 100 watt panels out there. So you have a pretty good farm of panels to be able to recharge one of those units. So when they talk about solar, sometimes it's kind of not practical to recharge these things very well. You might get a little solar power that comes back in that might help you, but to really recharge it, it takes an awful lot of panels out there to run the things. So here's a couple close-ups of the units. The one on the right is the main has the main inverter in it. The one on the left is pony pack that just has lots of batteries in it. So let's see. Yeah, so like if you have a power outage during the winter It's if you want to recharge it with solar, it's going to take you forever, and you're going to need an awful lot of panels. Those units usually run about 100 pounds. You know, they're on wheels, so it makes it pretty nicely. Base price out of that main inverter there runs usually somewhere around $3,000, and you can add extra battery packs for about $2,000 a piece. So they're not cheap, but they are kind of a little bit convenient, but it's kind of limited if we're going to have a power outage for any limited amount of time. If all you need to do is bridge your time for maybe the power being out overnight, one of these guys will probably work just fine for you. But you're counting on the next morning when you wake up for those linemen to have that electricity connected back and operational for you. If you try, and again, if you try running water heater, water pump, heat pump, anything like that, it's going to end up draining that battery really quickly. So my point here is that these things are not well suited for long-term outages. So let's look at another thing that's come up, and that's the good old Ford F-150 Lightning. And I think you've seen it getting a lot of press out there. So let's see what this guy has to offer. Not suggesting we go out and buy a $50,000 truck out there just to power our house, but it's an interesting comparable. So it's a totally EV truck, so it's not a hybrid, so it doesn't have a combustion engine in it. All it has is a bunch of batteries in it. So you can get this guy with extended range. That means it adds a bunch of extra batteries. So that unit can support 131 kilowatt hours of energy. That is a lot of energy in batteries, huge. So the one limiting thing on that is the inverter that they have in there. That inverter will only crank out about 7.2 kilowatt hours, but that's 220 volts AC. That's pretty darn good. That's a 30 amp service at 220. Pretty nice. Average house again needs around 30 kilowatts an hour. So a fully charged Lightning truck can operate a house for on an average of 3 to 4 days. If you really ration that power, but again, you're with the 7.2 kilowatts on the output of the inverter, you're not going to run all your appliances. You're going to be limited on what you run. So like you could only run your hot water heater. You could not run your hot water heater and a water pump at the same time, or a stove at the same time. These bigger appliances, you can only run one at a time. So you have to manage that on how that works. So if you ration your power out of one of those Lightnings, you might be able to get 9 to 10 days out of it. You're probably not going to drive that thing back to work afterwards, but at least you can take and keep your house alive for that period of time. So that's kind of an interesting little twist there. Thought it was interesting to talk about. So let's talk about batteries for storage. And when you start getting into this subject, there's a lot of things to consider, and pros and cons and good and bad, but let's wander through it and we'll see how this thing works out. So the old lead acid batteries that we've always had in our automobiles for eons, or for our RVs for deep cycle lead acid batteries, we've had those around for a long time. Lithium has been around for quite a while. The new guy on the discussion list here is the lithium iron phosphate LiFePO batteries. So they're the newest ones around. So let's talk about just strictly lead acid batteries. Typically for storage, you think about things in battery sizes of around 100 amp hours. 100 amp hour deep cycle battery is going to run you about $150, and that'll give you about 100 amp hours of use. They are very heavy. They're toxic because you have lead and sulfuric acid in it, and both of those substances are not kind to our world around us. Things that you don't always think of is that your battery is rated at 100 watts, but if you pull out more than about 50% of the power out of that, you're going to start derating. You're going to start hurting that battery. It's not going to have as much capacity as it had before. So typically you only want to discharge it about 50%. So you're only going to get 100 or 50 amp hours out of that thing at all. So if you completely discharge the charge cycles, you can usually get between 300 to 500 complete cycles out of that before they're kind of spent. Very slow charging rate. When you seriously discharge one of these batteries, it's going to take you between 8 to 10 hours to recharge that. And that's just that's a factor of physics of how the chemistry works there. So think about that long, slow recharge process. You also have to store these things in a place that has very, very good ventilation. Lifespan on these batteries usually are 3 to 5 years. They do require maintenance. You have to, when you're using them heavily, you have to take them out of service, check the water levels in it. You have to clean the corrosion off the contacts. So it does take some maintenance to keep these things functional. Other types of batteries in the same category of gel cells and glass mat, AGM type of batteries. Lithium batteries been around for quite a while. Usually a 100 amp hour battery there will run you about $600. They're about 30 to 40% of the weight of a lead acid battery, so they're much lighter, much easier to move around. Usable discharge rate. This is a big change. You can discharge those things by about 95 to 98% of its rated capacity. So out of that 100 amp hours, you're going to get all the power that thing has stored. You can discharge and recharge those things. They're good for about 1,000 to 3,000 cycles. So they'll last much longer. Charging rate. So these batteries here, you can easily take 30 to 50% of its rated capacity and run that current back in there. So you don't have this long charging rate. Now, one thing to consider is that if you got a whole bunch of these batteries, if you got, a kilowatt worth of batteries out there, the amount of how you end up generating the ability for it to charge is going to take one heck of a large charging device to end up putting that energy back into it. So it's really nice that it charges fast, and all the energy that you create goes right back into it. But you're going to have a big expensive device to recharge it. Lifespan easily 5+ years. Maintenance free. You don't have any maintenance once you connect them all up. That's the end of it. You don't worry about it. The one downside on these is that you can't charge those things when they're below 32 degrees. And I'll have more to say about that in shortly. So the new guy in the block is a lithium phosphate. Again, these guys are 100 out. You can think of these in 100 amp hour chunks. Cost to own is a whole lot more expensive. Here you're talking about $800 to $1,200 for one of those batteries. There are a bunch of new stuff on the market that is down in the $500 to $600 category. If you look closely at the quality of what you're getting there, you'll find that these batteries, rather than a 10-year warranty on it, they only provide a 5-year warranty on it. So you get something cheaper, but it basically will last about half the life of a more expensive device. Lower lifetime cost, and I'll get into the dollar signs about what that really means. Lightweight, 60% of the weight of a lead acid battery. Very nice. Same old, basically 98 to 95% of the rated capacity you can get discharge out of it. charging cycles, you can easily go between 3 to 5,000 cycles out of that. That's huge. Lifespan 20 plus years. Charging rate. So if I can take 100 amp hours out of that thing, I can pump 100 amp hours back into it, and that guy will take the charge. Again, you're limited by what you have for a charging system to be able to put that kind of power out and put that energy back into those cells. Maintenance free, no ventilation required, eco-friendly. This stuff is all recyclable. And so it's really, really cool. And again, same kind of problem. Won't charge when it gets below 32 degrees. So the way this is normally handled is the batteries, you can buy these batteries that have a heater in it. And so that has a little wrap around it that has a little heater in it. Now, if you go through there and add some extra insulation around that to hold some of that heat in, literally you can create, it'll take like 3 watts of heat, will keep this guy above 32 degrees. So you can run it down to like almost 0 with insulation around it, and literally 3 watts of power from the battery will keep that thing above that 32 degree mark. And then so it only comes in on when the temperature starts getting down around 32 degrees. So you're not just using that all the time. But 3 watts out of 1 day, that's basically equal to 72 watts of energy out of a 100-watt battery. So, and it's not like it's going to be probably on all day long. It's probably only going to be on 3 or 4 hours during the night and the morning that would be on in order to keep this thing above 32 degrees. So there is ways of working around it, and that seems to be the most economical way that works well for everybody out there. So let's talk about the dollars and cents. Average U.S. homes uses around 330 kilowatts per day for one day. Lead battery. So let's say you need 50 of those things, 100-watt capacities. So you put out basically about $7,500 to buy these 50 batteries. In about 3 years, these batteries will be well used, and it'll be about time to, and this is assuming you're going to use them a lot. So that means your cost per year is around $2,400 per year for these batteries. LiFo batteries, because you can get 100% of the power out of it, you only need 25 of them. But the cost of buying 25 of those things is pushing $20K. Really, really expensive. These batteries, you're probably going to be able to get 20 years out of it, but just for comparison, I just picked 10 years out of it. So let's say these batteries only lasted 10 years. These batteries will still be working, and it will only cost you $2,000 per year when you amortize the cost of those batteries. So after 20 years, that means only $1,000 a year for these particular batteries. So, but people are going to have a hard time choking on trying to come up with 20K for just batteries. And a lot of people drop back to the lead acid batteries because it's much cheaper, the buy-in cost. But overall, your cost for operating over that period of time is going to be a lot more expensive. Interesting point here. So let's talk about the next subject, and this is how we end up getting power into or emergency power into our house. So there's thinking about that. And that's, plug each appliance into a generator or power your house through your circuit breaker panel. So let's see, I'm trying to remember. Okay, so one of the ways that I kind of do things when I live in a very rural area, and we're well known for getting torn up from ice storms and means that we're pretty rural, not a lot of people on the power lines there. We're always the last to get our power back, so we can easily be out of power, commercial power, for 3 to 5 to 7 days. So what I like doing, my things that are really important, and that's my refrigerator to keep my beer and pizza cold, microwave to heat up my pizza, a TV, and a few lights. I got a wood stove for heat, and I'm very happy with that. Now, I do like to take a bath once in a while, and I do like to end up flushing the toilets once in a while. But with that little, just those appliances there, I have a little Honda 2000 watt generator. It's a small inverter, so it's very friendly to electronics. It sips fuel, and so it's very, very conservative on the fuel. And all I do is just run some extension cords around the floor of the house there to the appliances that I want to operate. And during the daytime and late evening, that is just fine. And then in the evening, I have a great big 17 kW generator that I crank up. It runs my water pump, repressurizes my whole system, runs my hot water heater, runs the stove, virtually anything else I want to run in the house. So I run that for about an hour and a half, cook a really nice meal, get a shower, nice warm shower, and then I shut it off and drop back. A friend of mine down the road, he had a 17 kW generator, had a 15 kW generator, and we had a power outage for 5 days. And every day he was going into town to buy 15 gallons of fuel. He was going through 15 gallons of fuel every day running that great big 17 kW generator. For me, for the 5 days that we had no power, I used 15 gallons. So what he was going through in one day, it lasted me for that entire event without having power. So getting power in when you have a partial house or a full house generator, or you need some way of getting power into the house. So the main thing that you have is that there's 2 ways of doing it. One's called a transfer switch. The other one's using an interlock, and I'll break that down in a little bit to show you what that means in the house. But what both of these methods do is that they prevent whatever power you're generating for your house from going back out onto the commercial wires. Do not want to energize the commercial wires because you are likely to have a lineman out there in the process of trying to repair it, and you certainly don't want to electrocute a lineman standing up in a bucket or standing up on a pole or on the ground with the power coming from your generator. So both the transfer switch and the interlock basically breaks that and prevents any of the power that you're generating in the house from going back out onto the power lines. So this is a very, very simplistic view of an interlock. And this is a mechanical device. So generally at the very top of your power panel there, you have where your mains come in. And that's where it says main breaker. Up there you have 2 of them, both for L1 and L2, which makes up your 220 volts that comes into the house. Down on the lower left-hand corner, in this example, you bringing in the generator from outside. There's usually a connection on the outside and how that power gets in there. So if you notice that right now, the way that interlock is setting, it has the power coming in off of the mains, but you can't take and throw that breaker arm on the generator. It's blocked out. It prevents you from bringing any power in from outside the house there from your generator. So once you go through there and flip the breaker in the off position for your main breaker, that mechanical slide moves to the right and then now allows you to take and engage the breakers for the generator. So you've disconnected the power going to the outside world on the mains, and you now allow your house to be connected to the generator. So that's how a mechanical interlock works. We're on consumer power here, and one of the neat things that they promote there is this little device called a GenLink. And this is a product that basically, rather than having to do a bunch of wiring on the house, what they do is that they pull your power meter off your panel. They put in this tan device on the right side, plug that in there in place, and then plug the meter right on top of that. And you can see that little black knob on the bottom there called GenLink. That basically unscrews, and that's where you plug in your generator. So this has automatic ability where when it sees the generator on, power coming in through that socket there, it disconnects things from the main. And this is something that means you don't have to go through inspections. You don't have a whole bunch of other red tape that you have to go through when you normally bring a generator power into your house. Because this is all completely provided by consumer power, or wherever your utility is. So let's get into transfer switches. So here's a very simplistic transfer switch. Now, most of the time you're going to be putting in a generator that is only going to run part of the house. It's not going to run 100%. So all those circuits that you're going to run goes into this particular panel. They basically get plumbed out of your main breaker panel into this sub panel. And then there's a device here on the left side there, that chunk there is actually a transfer switch, which means that it will end up transferring all the power to this panel to take and operate it. So let's see. So yeah, if you don't have a whole house generator, you may need to install a sub panel. That's what I just described there. Contains all the electro circuits that will run from the generator. So here, that guy there has 8 circuits that you can run. You're not close to the whole house. So here's a bigger one. This is a big 30 amp guy. So he handles 220 and a bunch of other stuff. This is just a bigger guy from what the other one is. The other nice thing about this guy here, it has a couple meters up on top. So we can check each leg, your L1 and your L2, to see how much current each one of those legs are drawing. So you know if you're going to end up kind of tipping the scale and possibly popping a breaker or having a problem with not providing enough power for the rest of your house. So transfer switch, unless you are, okay, here's some safety things to at least be knowledgeable about. Unless you are an electrician, do not attempt to install a transfer switch or a sub panel. It really requires an electrician to do this. Remember that any of this work that you're doing, except for the one that I mentioned there about the GenLink, that one, you're going to have to go through a permit process. You have to go through the inspections. And that's just required by your county and city. So it's a lot more stuff you have to go through to get that done. Remember, not doing your own recommend it, not doing your own subcontracting. If you're going to bring in a generator, it's actually better if you just contract with one individual out there to do the whole thing, to make it a turnkey system. I know too many people that something that should have taken 2 weeks to do took basically 9 months to do, trying to work around different subcontractors to get the work done. Better done by just one person. And likewise, if you have any problems, you only got one person to take and deal with. So there's 2 kinds of transfer switches. There's some automatic ones, and there's some manual ones. Manual ones is where you have to go out there and physically start the generator. You have to flip the switches to transfer to to disconnect from the mains and to connect your generator to your house. And that's Yeah, pretty straightforward. You do all the work. If you're talking about an automatic one, it'll detect that you lost power. It'll start your generator. Once the generator's up to speed and warmed up, then it will transfer all the internal house to that generator. When it sees that outside power has come back on again, it'll disconnect and shut down the generator. So it does all the work for you. Obviously, there's a difference in price in these two. Couple more safety things. Never operate your emergency power system at a sustained 100% capacity. So any generator or anything that you have out there, if it's rated for 100% capacity of 20 watts or 30 watts, or 30 amps rather, or 20 amps, don't run it at that. If you run it at that point in time, it's going to end up having a shorter lifespan, and it's likely to burn itself up or have some undesirable things that happen to it. In my first discussion, I talked about surge power and max operating power. Surge power is like for anything that has a motor on, like your air handler, like your water pump. When those devices first come on, they have probably 3 times the more energy requirements than what the normal operating power is. So you have to be able to size everything to be able to handle that surge power. Never connect a generator directly to your service panel without a transfer switch or an lock. That's just an absolute must, that you got to have that safety in there. Don't install circuit breakers that exceed circuit capacity. I've seen guys that, so you have basically 12 gauge wire going to some plug-ins, and they, because they have maybe a couple refrigerator or freezer and stuff, they'll put in a 30 amp breaker. That wire is not sized for that, and you will eventually burn that wire up. It'll get hot and then catch fire. So just never put in the wrong size circuit breaker for the wiring. Never work on live electrical circuits. Be very respectful. A lot of people don't think about solar or battery and household electrical circuits, about how dangerous it is. A solar panel, short circuit, you can easily create an awful lot of power that'll end up melting wires, melting connectors. Batteries, if you drop like a crescent wrench or a wrench on a set of battery terminals, that wrench will end up turning into a flying liquid molten steel. And believe me, it will burn through anything. And it does that in an instant. And we all know that 100 volts in household electricity, that's enough to stop your heart very easily. Always make sure that you have a carbon monoxide and fire detector. Make sure you change your batteries often, or at least once a year, whatever the recommendation of some of the longer extended batteries are good for 3 years. Okay, let's wrap it up here. And for solar systems, you still need batteries if you're going to end up using it for emergency. You got to have some way of storing it. Nighttime limits your battery storage. Winter months of very poor energy performance. So during the winter months, you're hardly going to get much energy at all. So it's going to be pretty rough being able to try to operate your whole house in an emergency during the winter. Battery systems, lead acid batteries must be ventilated out, and they must be outdoors. You just do not put lead acid batteries indoors. The outgassing of the hydrogen is a very, very explosive substance. So it gets very expensive. In other words, if the larger amount of storage you want, the number of batteries gets very, very expensive as you move up. Large investments when seldom used. So that's one of the things you have to kind of think about. How often do you use the darn batteries? It's only like once in a while, or maybe 2 or 3 times a year when we have some kind of outage, and like what's the benefits of that? That's why sometimes just a generator is just a better solution for it, because you just don't have that huge investment that you just don't hardly ever use at all. And also batteries must have some way of recharging it, and that can be problematic in some situations. So, any questions at this point in time? Let me get things back to find out where I'm at here.
Mike,
Come
I'm
on.
not sure I have a question. I have something that I found that I've been looking at as another
Okay.
solution. And I'd love to
Okay.
hear feedback. Let's see if I can successfully share my screen here for just a minute. And let's see here, screen 2. And so I happened to stumble upon this.
Yep.
And these, you don't laugh.
No, I'm not at all. I mean,
Yeah.
those are really huge workhorses.
Yeah,
And
so
but
another option.
Mhm.
And it's got a dual purpose to it. And I'm a little bit thinking about it because it not only operates as an 8 kilowatt generator, it does run on diesel. You can buy them for a song if you follow the auctions. And you can see this is rbauction.com. There's nothing hiding here. You can look on that site and you can see auctions all over the United States. I have not pulled the trigger on this because they're very well used pieces of equipment, right? I mean, they're put into harsh environments. But this one not only has an 8 kilowatt generator, but it's also a light tower, and otherwise known as take the lights off, and now you've got an antenna tower.
Antenna tower. Yep. Mhm.
So I've been sort of mulling it over, and I haven't done anything with it yet, but I thought I would add it to this wonderful presentation that Mike gave, and that there is another opportunity here to get something that is sort of emergency power, but then you can take it to like field day.
Well, okay, let's talk about a couple of details here. So, is this a generator or an inverter on this?
Let's see. I don't have all the details. I'd have to go to their website, Mike.
Yeah. Okay. So I'm pretty darn sure that that's a straight on generator. So that means voltage variations and other artifacts there for sensitive electronics may be a little bit of a challenge there. The other nice thing is that I have no idea about RF emissions on this. About if it would create a problem with RF emissions with an antenna stuck to it or not. So there's a few other little things that need to be looked at there, but actually at a long time ago up in Salem, one of the guys had a great big diesel and it was 4 times that size. And so it could run a city almost. But it was nice and quiet, and you had infinite power that came out of it. So if you wanted to run amps and stuff like that, you had no problems with it. But that was also is a diesel, and I never saw any bad emissions coming out of it.
Nice. Anyway, I thought it would be a great little thing to add as far as alternate energy for your homes, emergency power. And it also has wheels. You can take it with
Portable.
you.
Yep.
So anyway, I'll let other people ask questions.
Anybody else had any comments or any thoughts there?
I'll add a comment. Something that doesn't work, connecting an alternator to your bicycle wheel to recharge a car battery, just not going to do it.
A lot of hard pumping, isn't it? Real hard pumping. A lot of resistance.
Mike.
Yeah.
Scott here.
Yeah, Scott.
I was curious on the interlock that you showed. It was nothing more than that little tag that you just slide to the right so the circuit breaker can't be turned back on.
That's right.
Yeah.
Yep. Strictly mechanical. Strictly mechanical.
So you got to remember to do that. If you forget, because of the transfer switch, I mean, it's either the system's gonna connect or not, but this, you can plug in your generator. If you forget to throw that interlock, you're in trouble, right?
Well, you're not going to be able to get power into your house.
No.
Well,
With that
what-
inner,
maybe that's Scott.
with that interlock, the way that works, it cannot engage the breakers for the generator until you've disconnected the mains.
I didn't. That's the part I missed. Okay, I kind of came in late, so I missed that part.
No, it's a double, so one of them shuts off the breaker, the main breaker, Scott, while the other one allows the juice to come in through that breaker from the input of the generator. And so they both, one goes off and the other one comes on. And then
Okay.
once you shut off the generator, because power has been restored, you're allowed to push on the breaker because the mechanical switch.
Okay.
There's a name for it locally, and I can't remember what it was, but I had one in my house in Corvallis years ago.
Okay. Yeah, I wasn't familiar with the interlock. I was familiar with the transfer switch. So, thanks.
So,
Yep.
Mike, on that same manual system we're talking about here, that doesn't take care of the ground wire. So, do they do something special with that, or just let it be?
No, ground wire is common all the way across. They do nothing special with it. It's only the two hot leads, the
So-
the L1 and L2.
So somehow you get into a reverse polarity situation. You could be running juice
I'm-
across the ground wire.
Well,
I mean,
you're
granted, it
going
ought
to
to go to
have
ground. You ought to have ground, a good ground.
you got to
posting.
have ground because on the 110, that's what it uses for the other half of the 110 circuit. If you're running 220, then it's just those two guys going back and forth on opposite cycles. So, but the ground is grounded. I mean, it's common to your generator, common to your incoming power and everything else there. So, that's nothing. I mean, because that's down, supposed to be at ground potential. That's not something that even the guys on the power line are going to have to worry about.
Because that should be that'll get you.
Any other good questions? Okay, thank you guys. Anyway, that was I thought that
Yeah.
it was most interesting coming up with that Ford Lightning. I was really, they advertised it on TV and I said, oh, there's got to be a gimmick on that. Well, there is kind of a gimmick. I mean, it's only 7.2 or was 7.4 kilowatts on that inverter. You can actually get 9.6, but that's the other 110 plugs that are in there too that you can get a little extra juice from. But that's just not practical for plumbing into your house there. But I thought that was a very interesting analogy that they actually, it kind of does what they say it does. Okay, that's it, folks.
Thank you, Mike.
All right.
Paul?
Great
Mike,
presentation.
that was a wonderful thing. I had two major takeaways. And the other one was I just sent a note because I have CPI too, and I've been looking to put in a generator, some sort of a ready to backfeed my power, even if it's just 3,500 watts or something, whatever I can plug into it, like one of those light towers. So I'm gonna reach out to them and see
Yep.
if there's something I can do. Thank you. I'll
Yep.
find out tomorrow.